Okay, in this part of the lesson, we're actually going to have to take it to the next level of adding and subtracting using scientific notation. But this time we're not going to have the same exponent on those base of 10s. So we're going to first convert our numbers so that they have the exact same exponent of 10. So this one's kind of tricky because of this 5. If I were to write that out in scientific notation, it would actually be 5 times 10 to the power of 0. There are 0 spaces that we would have to move. Now remember, anything to the power of 0 in a previous section would equal 1. So 5 times 1 still gives me that 5. So we're going to write it out using scientific notation of 5 times 10 to the power of 0. And then we also have where we're adding 7 times 10 to the power of 3. Okay, so here's where it gets kind of tricky. We have to first convert both of these numbers so that they have the same exponent. So here I have an exponent of 0, and here I have an exponent of 3. So it doesn't matter which one you choose to convert it to. You choose, you want to have it so that they both have an exponent of 0, that's fine. You want to have it so that they both have an exponent of 3, that's okay too. You're just going to pick one of them. That set you're going to leave as is. So I'm going to go ahead and convert this so that it has an exponent of 0. Okay, so the key thing on this is when you're converting your number, you must have the new common exponent and the sum of the exponents must equal the original. So I have to get my exponents to equal 0. So while I have to do what I want my new exponent to be, which is 5 times 10 to the power of 3, and then what would I add to that? Add to 3 to make it 0, I would add a negative 3. So times 10 to the negative 3. Okay, so now I want to leave this part right here, but I now have to convert it to get rid of this. So I'm going to do to the negative 3. So my decimal not shown right now means it's sitting here, and I'm going to go negative 3 places. 1, 2, 3. So I have 0.005 times 10 to the power of 3 plus 7 times 10 to the power of 3. Now we can do like we did in our previous video. Now we have the same base number or the same exponents on our 10s. So we're just going to go ahead and add, because it's adding right now, those together, which gives me 7.005 times 10 to the power of 3, final answer. And you should remember from looking at that previous video when I forgot that I hadn't taught this part yet, we still got the same answer, okay? Before, yes, we changed it into standard notation, and then we found out that the final answer was 7.005 times 10 to the power of 3. Here, we're not going to convert it, okay? This is a hard concept. You have to practice it, okay? In order to get good at it, you have to practice it. Okay, so here, once again, we have different exponents. So that's my first thing I look at. I look at my 10s and I say, do they have the same exponent? No, shoot, we're going to have to do extra steps. So what are our extra steps? Well, we have to convert our numbers so that they have the same exponent of 10. We're going to pick one. It doesn't matter. I'm going to go ahead and change this back one. Okay, so this one's going to stay the same. Now, for this one, I'm going to throw this minus sign in there so I remember I'm subtracting. I need to write this so that it has the new exponent number and that the other exponent and my new one have to equal negative 2. So I'm going to write it out as 5.5 times 10. I want to get it to 10 to the negative 1. So I like to write that one first. Some people write it second. I like to write it first so I can see now these have the same exponent. But here's the thing. I need a still times 10 to the something, and they have to equal, when I add them together, negative 2. So negative 1 and another negative 1 equals that negative 2. Okay, so now I have to shift because I can't have 2 of these 10s. So I have to shift my decimal to change this. So I'm going to go in the negative direction 1 place to get rid of this. Negative direction 1 place. So this is now 0.55. Done with that. Now I have the same 10s with the same exponent. I'm going to go ahead and subtract. So 2.4 minus that 0.55. Bring my 0 up. Now I'll do my subtraction. 13 minus 5 gives me 8. 1, bring my decimal down, so it's 1.85 times 10. My exponent that I chose to use was -1. This is my final answer. Now, sometimes on these, you're gonna have to move your decimal. This one I didn't. I only had one number in front of the decimal. Sometimes you will have to. It usually happens more often if you're adding, but sometimes it does with subtraction too. Okay, this is tricky. This is one that's kind of hard to teach it. So I'm just trying to break it down as easy as I possibly can. Okay, it takes practice to get comfortable with it. Okay, so we're gonna look first. Do we have the same exponent? No. Which one do we want to use? I tend to use the one with the bigger exponent, but it really doesn't matter. So I'm gonna keep this front one. That's gonna stay. 9.7 times 10 to the 6. I need to rewrite this so that it's got 6.7 times 10 to the 6, but I have to really have another times 10 to get it to equal 5. So let's see, I would have to do 6 minus 1, so I'm going to do a -1 to get 5, right? 6 minus 1 would give me that exponent of a 5, okay? So now, to get rid of this part, because I want to keep the same exponent one, I'm going to have to move my decimal -1 place, -1 place. This now becomes 0.67 times 10 to the 6. And I have a plus sign up here that I need to remember to bring down. And 9.7 times 10 to the 6. Now we're going to do like we did in the previous part of the previous video. We're going to add these together. So I'm actually just going to bring this down. So plus 0.67. I have a 0 there. 7, 13, carry the 1, 10 times 10 to the 6. Okay, not done. Here's why, and this is what I just got done talking about on the previous one. This is not in proper scientific notation because I have 2 numbers to the left of the decimal, so I need to shift 1 place. Okay, it was greater than 1, so that's a positive thing, so plus 1. It now becomes, for a final answer, 1.037 times 10 to the 6 plus 1 is 7. Here's our final answer. And that should look familiar to, I used the same problem when we were doing the standard notation. Okay, so once again, practicing those skills. We're gonna go through one more of these. And this is a tough concept. You just have to practice it, practice it, practice it, practice it. Okay, so let's try one more. I'm gonna keep this front one. I tend to do that. So I have 8.2 times 10 to the power of 2. Now I want this to have times 10 to the power of 2. So 3.41 times 10 to the power of 2. Now I need to get times 10 to the power of something that when I add 2 to it equals -1. So 2 plus a -3 would give me -1. I'm thinking like this, 2 plus n equals -1. If I were to do -2, I'm doing this in my head, but some people don't understand that. So write it out. I get n equals -3. So this is going to be a -3. If you have to do that, do that. Okay, so now we have to use this and convert here. So I'm going to go -3 places on this. 1, 2, 3. So now I have 8.2. We were adding plus 0.00341. Put my zeros in there. Now I'm going to go ahead and add 14302 decimal 8. That's in proper scientific notation. So I'm just going to bring down my times 10 to the power of, what was common? 2. If you choose to convert it to the -1, you're still going to get the same answer. It's just that you're going to have to, once you do it, I would have used the -1, I would have had to move my decimal, okay, to get it to proper scientific notation. So once again, the rules that you need to do, you have to convert your numbers so that they have the same exponent. Pick whichever one you want. Then move so that you eliminate the extra. So you have to take it times the new exponent and then make sure that you have the sum of the two equal the original. You're going to move your decimal. Then you're going to add or subtract. And then if you need to, you'll have to convert to proper scientific notation.